Again, continuing with simplifying one-term exponential expressions. Remember, there were two steps. Whenever we're dealing with one-term expressions, all we needed to do is prime factorize the bases, and then we apply the exponent laws. So if we look at this, we can see that 2 is clearly a prime number, 3 is a prime number, so is 2. So the main thing that we need to do from here is we need to look at 18 and say, let's prime factorize that before we start applying the exponent laws. So I'm going to do that over here. I think I'm going to go across and then I'm going to work into the next line just to make things a little bit more spacious. So let's take the 18 and let's say let's prime factorize 18. Well, that's an easy process. I say 18, 2 times 9, 9 is 3 times 3. All these numbers in my expansion is prime, so 18 is equal to 2 to the power of 1 multiplied by 3 to the power of 2. So that's going to be as simple as saying 2 to the power of 1 times by 3 to the power of 2 raised to the power of x. That's going to be multiplied by the following. 2 times 3 to the 1 minus x, all to the power of 2, divided by 2 to the power of x minus 1. So at this point in time, I haven't done much yet. I've just ensured that every number in my expansion is expressed as a product of prime numbers. 2 times 3 squared, 2 times 3 to the 1 minus x, and 2. All of these numbers that I see over there are prime numbers in the bases, right? So let's go to the next line, and let's apply the exponent laws. Now, this is something, and this is something else, raised to a power. So remember the exponent law a b to the power of m. This is simply a to the power of m times by b to the power of m. The same thing applies if I've got a to the n, b to the m, raised to the power of p. That's going to be a to the n times p multiplied by b m times p. Okay, so let's look at that. Let's say that's going to be 2 to the power of x. That's just applying simple exponent law multiplied by 3 to the power of 2x. Right, multiplied by 2 raised to the power of 2, multiplied by 3. Now remember, this is a power. This power is 1 minus x. And what you really need to do over here is you need to take the 1 minus x and multiply it by 2. So the entire thing, it's like foiling it out. So that's going to be 2 minus 2x. And that is all divided by 2 to the power of x minus 1. Okay, so what we can clearly see now is that I've got things with the same basis, and I can just apply the exponent law to 2. I can say that's 2. Take all the exponents where 2 is involved, the base of 2, and then just add them together. That's going to be 2 plus x. And then I can say, okay, the denominator is going to be 2 to the power of x minus 1. And then this is multiplied by 3, and we just take all the powers of 3 and add them. And that's going to be 2x plus 2 minus 2x. Okay, so here you can already see some of 2x minus 2x. That's obviously 0x. Okay, and this over here simplifies into the following. Let's take the 2's. That's going to be 2 to the power of 2 plus x minus x. Oops. Minus x minus 1. Right, because I'm taking the powers of 2 and the denominator where I have 2 in the base, and I say that top power minus that bottom power, which looks like this, and I multiply that by 3 to the power of positive 2. Okay, so let's see what we get over there when we simplify this thing out. 2, that's x, that's going to be negative x, so x minus x, right? X minus x is no more x, and 2 raised to the power of 2, this, when I multiply this out, that gives me positive x, and this gives me positive 1. Negative x and positive 1. So positive 1 plus positive 2 gives me 2 to the power of 3, and x minus x cancels, and that leaves me with the following. That's 3 squared, which is 9. And that simplifies into 8 times 9, which is 72. Okay, so that's example number 4. When we simplify one-term expressions, I will select a series of exercises for you to complete on the learning platform in the next section, and then some online exercises as well. Okay, and then we'll move on to dealing with expressions that have multiple terms that involve exponents and how to simplify them.